Okay, so today we're going to be doing question 155, minimum stack for LeetCode. In this question, the question is asking us to design a stack that supports push, pop, top, and retrieves the minimum value elements in constant time. So, what does this mean? Well, it's basically just asking us, given the class called minimum stack, to create a stack, being able to have the functions that most stacks have, which are just the pop, push, get the top value. However, what makes this question unique is that they want us to be able to also get minimum, to be able to have that method within this function. And in order for this get minimum method to happen, we cannot just loop through the stack and find the minimum value, but instead we need to implement a solution with O of 1 time complexity. So because it's O of 1, we cannot loop, because if we're looping, that's going to be of O of n, and that would not match the time complexity this question is asking us to have, which makes this question a medium one. However, it's not that complicated, and I'm going to explain to you the thought process and how we get the answer to this question. So, if we're creating a stack, the first thing that we could do is actually, ironically enough, create a stack, right? So we're just going to do self.stack equals, and then these brackets, and this is going to be our main stack. Now, remember, most of these things are pretty simple. If we create a normal stack and we want to have a function called push, and we want to push things into the stack, well, all we would do is self.stack.append, right? And in the argument, we have a value. So just add that value, and boom. Because we know when you do stack.push, that typically means, okay, let's push this value into the stack. So all we need to do is just .append, push the value within the stack that we just created, right? And same thing for pop. Pop, we're just going to do self.stack.pop, nothing crazy. For top, it's going to be the same thing. We're going to return, however, self.stack at index -1, and the get minimum is for the next step. So we're taking a look at the code, and we've basically done the majority of everything we need to do for a normal stack. However, keep in mind, we need to get the minimum stack, the lowest value within the stack, and the way we do that is by creating a whole separate stack in order to trace this minimum. So let's create a minimum stack right here. Beautiful. And for the push function, what we're going to do is we're actually going to create a variable to hold the lowest value, right? So instead of looping through O of n notation, we're just going to be consistently updating this variable called value and adding it to minimum stack if it's the lowest value, right? And that means if we do this, that the latest number will consistently be the lowest. So we have value, we've created this variable, and we want to update it so it's consistently the minimum. So we know that we're going to have to be using the minimum method if that's the case, which is what we just wrote, minimum. And what are our arguments going to be? Well, our argument, one of them, definitely has to be the value that we're in currently, right? Because we're kind of trying to see if the value we're on currently is lower than what we have. So we have value, and then we need to see what we have. So if we try to see what we have, then we just need to do self, and then what we have would be in the minimum stack, and we're going to get that for index of -1. Perfect. And with that, however, we need to do some if statements just to make sure that our edge cases are in place. And our edge case, we're actually going to write this within the same line. We're just going to do if self.minimum stack, which means, okay, if minimum stack has values, then follow what we just did. Because remember, this line right here is grabbing self.minimum stack at index -1. That means that minimum stack has to have a value, which is why we have this section of code, if self.mini-stack, if they have values within the stack. If not, then all we do is just else and then val. So what this means is, okay, we have a variable called val, update it so it grabs the minimum of val, the argument we're on currently, or self.minstack -1. So whatever the value is at index -1 for min stack, and -1 is just the last thing outputted, right? So we can consistently have the lowest number, right? And we do this only if there's values within minimum stack. If there's not, then just add the value that we're on or whatever the argument may be, because that will be our lowest value and we can consistently be updating it. So with that being said, all we need to do now as we have this value is just add it to min stack. So self.min stack dot append. Oh, this is a capital S. And then the value. Perfect. And then for pop, it's the same thing, right? This was basically the majority of the work right here. Min stack dot pop, right? And then for minimum, all we're going to need to do is just return. So return self.min stack at index -1, and everything should work now. Let's give it a run to see if we are missing anything. Beautiful. Let's give it a submit to make sure that we pass all the test cases. Yes. Okay. Beautiful. So with all that being checked out, just another quick run. So make sure that everyone has an understanding of how this question is phrased, what needs to be done, and etc. So for this question, minimum stack, right, we are basically creating a stack. We want to create a stack, hence why this class is called minimum stack. And we want to be able to have the same features such as push, pop, get minimum. However, actually, no, get minimum is not one of the usual features. Scratch that. We want to be able to push, pop, and top, right? Those are usual features for stacks. However, for this one in particular, we want to be able to get the minimum, right? This is a unique thing, and this is kind of the whole premise of this question. However, instead of doing an O of n, we want to be able to do an O of one-time complexity. And the way we do that is by actually consistently updating a value and adding it to the min stack so that we always have that lowest value ready to be given to us, even if we push or pop. So most of this stuff is very self-explanatory. For this function right here, we're actually just creating the stacks. So we have the normal stack and the min stack. For the push function, we are automatically just doing .append the value that we have into the normal stack, because if it's a normal stack, all we got to do is just add a value, right? However, for the minimum stack, because this is a unique feature, the way we do that is by creating the variable, right, and grabbing the min or the lowest and consistently be updating, right? This is what allows us to do the unique method within this class and be able to do an O one-time complexity. The popping and topping is just very self-explanatory. Pop is to remove something, right? So all we need to do is self.stack.pop. Same thing goes for the minimum stack that we created up here. And the get min to get the lowest value, the thing that we've been trying to do. All we need to do is return self.minStack at index of -1, which would be the last value. The last value will always be the lowest because we are consistently updating and making sure that value is equal to the lowest between the argument and min stack at index -1. And we say if that has values in it, else just add the value that we're on, aka the argument.